Hello everybody. Thanks all for coming to this. This is a talk about how to avoid becoming an ornamental data scientist, and I will explain what that means in the coming slides. We're part of the RSS Data Science and AI section, which I myself are from that section, and we've been going around and doing a load of different talks to understand what is it about the future of data science that we can teach others, and how can we as a community come together, become better practitioners, and hopefully not get left on the shelf. So this is the section. I'm putting this up there to kind of point out a few interesting things. Obviously we've got Trevor here. Oh, sorry. We have Trevor just here. Piers Stobbs, who is the VP of Data Science and Delivery, does an incredible newsletter. So if you're interested in a monthly newsletter that covers all manner of topics, I don't know how he does it every month, but he does. It's astonishing. I'd really recommend signing up for that. Below that, Dr. Martin Goodson, the London Machine Learning meetups. They're mainly online, so you don't have to be in London for them. But he gets some really top-class researchers to come in and speak about machine learning every, I'd say, month, 6 weeks. And like we're talking top-class researchers, so I'd recommend joining that. And I know a lot of people at the moment are talking about regulations and AI governance. So if you look up Florian Osman at the bottom there, he's done a whole load of work with the Turing Institute to put in place the governance and regulations for AI in different places. So those are a few people. I would look at them, and you can see there's lots of smart people, and I'm the bottom one there, I'm Will. And the point of us, really, is a little bit different from some of the other talks. We're not going to talk about methods, we're not going to talk about techniques. We're going to try and promote what makes data science great from a statistical point of view, but also a career is a lot more than just a method, and pushing forward the debates about what we should be doing from a policy perspective, as well as kind of the social and ethical implications, is really important, because things have changed a lot in the last 15 years. I think data science as a concept wasn't invented past 2010-ish. So things move quickly, and we're trying to stay on top of that to make sure that people have kind of full, sustainable careers. There's your name. There's your name. So we said we'd have names, and we do. So what we've done is we've gone around the country, went to Cardiff, Glasgow, London. We did miss out Northern Ireland, though I did try and organise something and we failed to, so apologies Northern Ireland. And we've done talks with those local communities to understand how do we become more effective practitioners? How do we avoid becoming ornamental? How do we avoid the pitfalls within a career pathway that means that the work that you doesn't feel valuable? And I don't know about you, but I've heard a lot more people over the last year or two worrying about this, about people saying, I'm not core of the company I'm working at, or the organisation that I work at sees data science as an extra, an add-on, a little bit, not unnecessary, but nice to have. And we want to push against that, because we really do see that this is, I'm not going to use the word untapped potential because that's such a cliche, but we've not gone anywhere near what we could do yet. And so we need to work together as a community to make sure that we plot a path that creates value. And that will lead to, hopefully, a sustainable and rewarding career in data science. That is a gnome. I think that's meant to represent kind of a hipster gnome, which was as close as we could get to a data science gnome. We asked people what they thought, and there was quite a lot of frustration. So we asked people, what most frustrates you? An overwhelming number of people said the top left one, which was too much hype about LLMs. And I'm sure you all see that everyone's suddenly started asking you, well, can you do this? Surely we can automate it all with ChatGPT. And then that leaves a lot of people thinking they're experts in it because they can do prompt engineering, which is hard, I'll admit, but not the same as statistical endeavors. There's a lot of hype. And on the other side of things, there's also a lot of people saying it's a terrible idea. And we're in this weird situation for the first time in the last year or so. A lot of people in this space are under a spotlight of saying what you're doing is either terrible or brilliant, and they're sort of missing the whole point of what we've been trying to do for the last 10 years, which is proper insight to make better decisions. So there's that low-quality discourse. People are also frustrated about other people. Working with people is hard, and we're going to come on to that in detail later. Low data literacy is something I'm sure you've all come across. People don't necessarily understand how to deal with data. they certainly don't necessarily care about the statistical side of things, which we might. And there's this big mismatch between what a non-technical person might think is the right thing to do. So you can, here you go, here's a load of mess, can you make some magic? And the gap between that and what's really going to be able to happen. On the public sector side, because there's a big difference we've seen between private sector and public sector, there's this idea that people are actually really risk averse as well, and they're not willing to try new things, which means that you don't get to do interesting things. And that leads us on to the infrastructure and regulation. IG is hard. I'm not going to talk about IG today because it's this massive topic and we could spend hours talking about the intricacies of GDPR, privacy and all the rest of it. But I'm very aware there's a huge barrier and we need to have a better conversation about it.
Is that information governance?
Information governance, yes. Information governance. Are you allowed to process people's data? And what are the legal ramifications or the legal basis for processing? Happens a lot in the public sector as well. The infrastructure behind those is a real frustration. And some interesting points about statistical power and software, which, again, are interesting and people are frustrated by it because it is a confusing landscape, but I'm not going to cover them today. That bottom right one I think is almost maybe the most interesting. We're going to touch on a little bit later is that feeling of being left behind. I know I certainly do feel like that sometimes because keeping up to date and feeling left behind are two very similar feelings. And it's a sense of guilt that you are not aware of everything that you should be, and that's something that I think is common across the industry. I think that's the third point there about MLOps and engineering is something that we need to invest more in as practitioners and makes it part of what makes us valuable, because insight and data on its own, if they're not brought into a business process, becomes much harder to maintain, and your role becomes much more difficult because it's constant. And then that technical career progression, I think, is a real challenge and something that we'll also talk about. I wanted to pause there and ask, is there anything kind of, in terms of big frustrations, anything that I've not covered here that people are feeling at the moment?
There is, so in terms of other people, so I'm from data science and LA team of data scientists. So there's one interesting aspect about other people is that everyone wants to do good things. So business wants to do good things, data science wants to do good things. But the problem is like how to build these teams, how to build collaboration. So it's kind of data literacy there, so people on the business side, they understand the value of the data. And yeah, but the problem is like how to make it work.
Yeah,
that makes sense.
The connection, the interfaces.
Yeah, everyone wants. Leadership, they want to do good things because they understand that there's value in the data and we need to be data driven to be competitive. Business, so, but sometimes things just don't work. And the question is like how to make it work, how to build collaboration, how to build this team. So more like organizational question, if that makes sense.
I think that completely makes sense. I think the interfaces between the problem, the solution, the infrastructure and the stakeholders is the job basically in a lot of places, especially if you're in a leadership position. We're going to kind of walk through a little bit of a journey, which I think all of those pitfalls come into, which is, I hope, covers some of that. But yeah, I completely agree. Organisational structure is something that's hard to feel responsible for, but you really feel the lack of when it's not there. Cool. So before I move on to some of the good things, I just want to do a quick poll of hands. Who here kind of classes themselves as a data scientist today? Half an elbow. You never say you are when you actually are. Always, yeah. And how many of you kind of been doing it for more than 5 years? Cool. Okay, so it's good. So there's for people in a kind of a longer tenure, they'll have probably gone through a lot of these pitfalls, and we'll talk about both the leadership positions and starting out. So how many people would like to start a career in data science as well? Is that something people are interested in? Great, a couple of people. Good. Good, because there is a lot to be excited about. So we ask people again, what are you excited about? What's bringing kind of the spice to, yeah, I want to get up in the morning and do things? As much as they're a pain in the arse at the moment, like transform architectures are cool, and like attention is interesting, and these are interesting statistical concepts, and there's a lot behind those that I think we can tease more out. So large language models as a structure, as an algorithm, I think people are excited about. Protein AI models, there's a lot there. I think the talk just on there about kind of functional analysis and shape analysis, something I know very little about, but fascinating in the way that you can represent data in that kind of 3D spatial orientation. Bayesian models and deep learning, I love that. That always makes me want to read more about it when it says that in a paper, and it's never really moved anywhere. Causal machine learning, causal, or like you can go through. There's some exciting stuff that we could get involved in, and this is making happy gnome, and we want to make more happy gnomes. So let's kind of get the space to make these gnomes happy, and we'll push forward. I know I was going to say medical diagnosis and application to healthcare. Rob's doing a talk on that later, so you should come along to his talk about the applications of deep learning for electronic healthcare records, and hopefully inspire some of you to do more. So we've got exciting things going on. And people do want to stick around. I was really pleased to see this, right? 83% of the people we surveyed, which isn't loads of people, admittedly, but hey, they responded. They are looking to stay in the field for the foreseeable future. So I think I was pleased with this. I don't know if other people have opinions. 15%, 70% of people leaving, that seems okay. That's sustainable. That's a sustainable amount of people, which means the field should be growing. And the data behind whether we should be is pretty interesting. There was a paper by the government released about data science roles earlier this year. 178,000 unfilled data specialist roles in the UK is the estimate. That's a lot of roles. And 60% of people who want to do AI can't. So there feels like there's huge potential. There's lots of problems. People want to do good work. Everyone's keen to do the good work. And what we haven't really nailed in the last 10 years is how we come together. Because ultimately there's a lot of change. And this is, I think, is kind of what's difficult for a lot of people is what are we doing? What is the role? There's a lot more specialization now that we're seeing, and it's important to differentiate these. I was going to be cruel and ask people if they had opinions about what the differences are here. I don't know if anyone does. Like a data engineer and a data scientist. Anyone have a go at that?
About 10K.
About 10K, yeah. Excellent. I think you could probably do the same all the way down there in different directions. Yeah, there's a machine learning engineer and data scientist. What does that conjure up anything different for you?
Yeah, I usually joke that no one knows what data science is.
Yeah.
Like it's such an umbrella term that my friend made a survey of companies in Latvia.
Yeah.
And about like, do you have data science? Do you have machine learning? It is horrible mess because everyone has their own definition. It's possible right now when things become kind of more niche. It's possible to say who is machine learning engineer and who is the data scientist. The data scientist, machine learning engineer is also a data scientist.
Yeah.
So you need to say something like a product data scientist. So yeah, it's a
mess, and I agree. And there's it's very confusing for people because, as we said, the whole point of this is we're trying to get the good work to happen. To do that, we need to communicate what we do. To communicate what we need to do, we need to explain what we do. And we currently have all of these roles that do different things. So I had a go. Data engineer, data scientist, as well as 10K. Pipelines, hates maths. Loves maths, hate pipelines. That's kind of first one. Machine learning engineer and a data scientist. One cares if a model breaks in production. The other cares if a model breaks in assumptions. That's I think, as close as I can get to something. Research engineer, state-of-the-art versus solutions. Those are the difference. And I think, a lot of people, I think, in the research engineer space it's a cool position, and I know some people doing it, but it is very research-focused. You don't necessarily see differentiations. It's closer to academia than it is to data science. And of course, this is a joke. There's very little difference, but it does seem to be that's the main one. If you're gonna build a very simple classifier, that's not a bad go, is it? R versus Python, and that kind of model. I think it's becoming a bit of a meme at the moment. The model.fit data scientist. It's the idea that anyone can be a data scientist. So they can type the words model.fit, and then magic happens. And that's just not the case. And I think we're seeing that in that there's this growing community of people who have got into it either through boot camps or kind of early career who feel disheartened because this doesn't work and doesn't deliver value because the underlying mathematical principles aren't there, which means the application of the right tools aren't there, which means that people and companies are disappointed. So I do think we could have another whole talk about kind of trying to pare back the model.fit data scientist, but we're not going to go into that. apologies to vegetarians. This is my best effort at explaining what I mean by an ornamental data scientist. The metaphor here is that these meals are companies. And on the left-hand side, I think is a great example of, I guess, the low-interest world we were in for a very long time, where there was lots of free money, and venture capital pumped money into startups, which meant that people could create these amazing products, and everyone wanted to sprinkle AI on top, machine learning on top, data science on top. And so data science, in some cases, became like the decorative flowers on a fancy meal. They looked great. They didn't add loads, but you couldn't really have a meal like, it wouldn't be a real Michelin-star meal if you didn't have some fancy flowers on it. And that kind of worked for a period of time, but the danger and the risk and the thing that I'm trying to talk about today to stop happening is that now we're not in that world anymore, and places are going to go back to what they know best, go to basics. The flowers will go first. And to really test the limits of the metaphor, data science should probably become more like the salt in the bottom right. It is integral to the flavor. You add to it, and without it, everything's a bit worse. Whilst the ornamental, decorative flowers, you probably leave them on your plate when you're done. So that's the concept we're trying to get to at the moment. Does that make sense? Yeah? Steaks? Steaks, flowers, salt. Steaks, flowers, salt. That's what we're going with. Yeah, my wife didn't understand that one either, actually. And this is the lovely theoretical data science flow. Depending on whether you're building a model and putting it in production, or whether you're delivering insight. You have a problem, you talk about the problem, you define it, oh great, you find the data, you work on the data, you do the munging, great, oh we qualify these models, we put them together, we evaluate them, wonderful, insight, we present it, everyone loves it, we deploy it, it works, we fix it, circle again. And I've seen loads of these in like talks and papers, and like they're great, and I guess they do sort of explain to people what data science should be, but they sort of miss all of this, which is actually the job. You've got deadlines, which mean you can't do what you just wanted to do. You've got stakeholders who piss you off because they want different things to what they said they do. There's politics because the person in another team actually wanted you to do it their way because they've got some funding. You've got your own team members to manage. You've got the management to manage who want something else that's different from the stakeholders because of the politics. Then there are competitors who do something different, which make your stakeholders and management want something different. Then everyone has a budget. The sales team want to sell something different. Your clients that you sold it to actually thought they were buying something else, so you need to change that. Then everything gets reprioritized because of the above. You realize you can't actually do it because you haven't got the IG sorted, so you have to start again from scratch. There's a security breach, so again you have to start again from scratch. And actually the person who built the pipeline originally wrote it in a language you don't understand, so there's technical debt to fix. And then you deliver something that wasn't quite what they wanted, and actually it's 2 weeks over time and over budget. That feels like that's the reality, and this is an idea. So given this, we want to go on a little bit of a journey through the series of pitfalls. So this is the journey we're going to walk through of how to avoid becoming an ornamental data scientist by going through these unsuspecting data traps. And they can leave you kind of a little bit screwed. So we're going to walk through the unspoilt lake. It's pristine, it's perfect. The domain desert, the random SOTA forest, a slightly faster horse. We'll veer past the Wizard of P and go into a very clever sausage machine to go past the faceless. Finally, we're going to walk the management tightrope and end up in a lovely home, a community of practitioners where everyone feels happy. That's the idea. And that kind of bottom right is a sustainable long-term career in data science that delivers value for everyone. So let's start with the unspoilt lake. How many people have seen these sorts of job adverts before? So it's like, oh my God, there's Naive Corporation looking to start a data science team. They're always American in this world, in my head anyway. Data science team to glean insight from terabytes of data. Opportunity to build a team from the ground up. Set our AI strategy as your data science skills to superpower our business. And then, of course, you have to say harness the untapped potential of data, because that's critical in all job descriptions. And what that implies to me is that there is a company which has a giant data lake that they've created, they probably spent a lot of money on, and then they've said, right, you need to do something with that, because that cost us quite a lot of money, and there's got to be some value there. And they hire someone to do this. And if I saw this job, I think this is the biggest red flag you could possibly imagine. Like this is going to be an absolute nightmare. Because what it means is no one's looked at it, no one's tried to get any value out of it, no one's checked this is any good, and no one really has any idea what data science should do other than it should be magic. So it's a pristine lake of what is probably under the surface, I don't know, shopping trolleys, at best. And I'll kind of go through an example that kind of I experienced really recently, kind of a few weeks ago. We did this thing during COVID, which was vaccine uptake across ethnicity and multiple innovation. It's just descriptive statistics, which people really like to understand for a given area, for a given age group, where are there kind of lower than expected vaccination uptake. And it's a really useful graphic, and people are, oh, this is actually important. That there are some clearly some real gaps in some areas where vaccine uptake is way lower than it should be. The bottom deprivation here is, I don't know how many people have heard of it, like a deprivation index. It's a measure of how deprived an area is, and one is very deprived. So this is a really powerful idea, and actually made a lot of changes in terms of how people spent money. And turns out there's this idea in the NHS called a community services data set, where all vaccinations are meant to happen. There's like 58 million people in this data set. It's a huge amount of things. And we were like, right, well, we could do that for human papillomavirus vaccine because, I mean, no one's ever looked at it before, but, I mean, it's all there. They have the scheme is there, it says what it is, it should be able to link to demographics, it's all there. What we found was that compared to the data they submit to the UK Health Services Authority, you can see that the percentage kind of uptake is really low. No one fills it in. No one fills it in because no one tells them there's no consequences if they didn't fill it in, so they never filled it in. And the ethnicity coding that they were meant to do, there were no consequences for not filling that in, so no one filled that in, which meant that we could sort of do analysis on 14 small places across the whole country, and we couldn't tell you anything about the impact of ethnicity on HPV vaccination. And this was a small project, it wasn't the end of the world, but if you joined a company and the whole point of you joining is to do this analysis, you're going to be in big trouble. Because my view is that if it's never been used before, it is unusable, like by default. For whatever you want to do, you won't be able to do it. And you've got to sort of treat these data sets as if they're deliberately trying to trick you, because they might as well be, because no one knows what's going on. And it's a risk because you're going to let people down, because people are going to think that you can do magic, and you can't do magic. So I would avoid unspoiled lakes of data. I think this one is maybe the most important, the domain desert, because whatever you're doing, like if you're a data scientist, you're going to solve the problem. You're going to use data to solve this problem. And if you're not the expert, you're going to get stuff wrong and you're going to look really stupid really quickly. People aren't going to trust you and it's going to go badly. So kind of the thinking through this, like how is the data generated, literally like what's clicked on what is the infrastructure that collects this? How does the system that collects the data then fit into the real world? How do people try and interpret that data in terms of the fields and all of that? How do people then turn that into language that people talk about? And then the bit that I think people sometimes miss, and speaking to people, is the translation of data science, like features, factors, things that we put in our model, compared to what a non-expert just knows. I don't know, you'll go to a meeting and they'll say, oh, well, this is wrong because I know that this thing is that. The number of people I spoke to last week with this, and I know they sell this many, and that's what I keep in my head. And if you don't know that and you've built a model that does things similar, you look kind of stupid. And there are a few real-life examples of this that I'll go through. There was online A/B testing, was an interesting one I heard of. They were doing, you've heard of kind of A/B testing online, a lot of people do this stuff, right? There's a cookie that got set to put you in the intervention or the control. And they were getting lots of positive results, like way more than you'd expect by chance, which was great, and everyone thought this was really, really successful. And then digging into it, what they found was that for Safari browsers, the process of setting a random number was slightly different in the way this had been implemented, which meant that there was a bias so that more people from Safari browsers were put into the intervention. Which meant that Safari browsers at the time were correlated with people who had money, because people had Macs, which they spent more, which then meant that all of the experiments were invalid. Which is a painful thing to find out, but like, unless you go right into the detail of like, what is the JavaScript function that sets this thing, how do I understand these biases, you won't know that answer. Another one we heard from in Glasgow, looking at cash machine usage in certain shops. And there was this one that just wasn't, they were way out, it was a massive outlier. And they went around and be like, trying to fit the model, trying to change things, understanding what could possibly be wrong here, this is real, is the model crap. And there was just a few places where they were literally hiding cash machines under stairs, and no one could see them. And like you had to go there to understand that, because in a lot of places you do have to go to where the data is generated in order to get the insight to be like, oh, of course, that's so stupid. Yeah, okay, fine. Like where the feature I did, location of thing in store, is it visible? And the final one that I think is a bit like this is how people get involved. I did a project once where you presented back and there was one category that was kind of way overrepresented based versus what I thought it should be. It was to do with what kind of category of people went into a hospital. And like, this is really interesting, it's really a real outlier, this is something we should understand a bit better. And kind of, so tried to talk to stakeholders and they go, oh, that's just the default drop down and no one really fills that in properly. Oh, cool, thanks, right. And that's if you looked at the form that generated the data, you'd see that that was an annoying thing to fit through. There was loads of categories, so people just didn't bother. And so that was like A in the A to Z list. And so all of these things mean that you've got it really wrong. So these are the ornamental risks that we're going to try and avoid, because you spend 3 months building a model that has data missing, not at random, so our cookie example, so your results are crap. The person you present your results to knows exactly how many dongles they sold, and they say you're wrong, and so you get out. The features you kind of create because you've done all this clever PCA, they come down and go, well, have you got this feature, like this metric I use every day? No. Oh, okay, well, you don't know what you're talking about. And what will end up being is you just do technical tasks that don't really relate to the real world, and then important work will go to the people who do know the data. And that's what you see. Oh, you're really smart, great, well, you can do this technical thing, I'll get the bloke who does it fast, who understands what's going on to do it. I thought this was mental. This is the random state-of-the-art forest. It's not quite a pun on random forest, it's good enough for the talk, right? The number of papers per month, it's crazy. Like, no one could possibly read that. And I think this is something you just got to take a deep breath and go, right, I am so far off being able to get anywhere close to this. Even if you specialize in like a specific area of machine learning or the statistical field of any kind, it's growing so fast that you'd have to read like a paper a week, which I would struggle to do given a full-time job and reading it properly and implementing it and understanding it. So I think people have got to be much kinder to themselves in this world. Like you're not going to learn everything, and you can't. This is the one that caught me recently. I spent way too long trying to understand it, couldn't understand it, never going to use it. It's not actually relevant, but I just thought it sounded cool because it hit the word, efficient Monte Carlo Bayesian optimization. Yeah, of course, there's a new framework. Fantastic. There's not really a good application for it, and I spent kind of a day trying to do it, and it was a waste of time. But the point is, you do still have to learn. Like, you do obviously have to keep going and keep learning, but you just have to be focused about it. And knowing when and how to apply an algorithm is obviously much more important than the latest and greatest. When was the last time someone used something that was like a really new approach that worked for them? Anybody? No, great, yeah. It's like the same old stuff every time, right? And it's simple and stupid first. I see this much more with the junior data scientists that you work with. They build something really clever and really complicated that falls apart really quickly because it's not simple, it's not stupid, and then it doesn't work. So
that's one of my interview questions.
Really?
What is the stupidest algorithm you've used that actually worked?
That's great.
It's a really good way of discriminating
Yeah.
applicants.
Yeah, I can believe that, because people want to say, well, they want to say, oh, well, I implemented a deep call to discovery algorithm to create a graph network and I fitted it with a Bayesian optimizer. And that's, well done, you did that. But Jeff, who's got an Excel, said, oh, I can just plot a line through that. And then he passed it over to an engineer who said, you just type in these numbers. And they go, yeah, I can do that in Scala, great. Oh, so it's in production. And that's the difference. And in terms of when we're talking about value, that latter one isn't as cool, but it is valuable to an organisation, and you've got to be comfortable with like most data scientists. We're not researchers. We're not trying to build your algorithms. We are trying to make things valuable, and that's the way to do it. But it's very tempting to go down that route, and it's sort of a balance act between you need to learn, but you don't want to get trapped in this forest of, oh, I can do cool new things.
Can I add your point earlier with how many ML AI? So
Yeah.
I work in COVID, real world data science, and my company AstraZeneca, we had someone doing every COVID publication,
Yeah.
logging it and keeping a list. There's far more than one a week. It was hundreds a week.
Yeah.
Like one a week seems almost achievable, but realistically, you have to combine that with your the field that you need
Yeah.
to know, the previous one, and it is absolutely unachievable.
Yeah, I mean, the reason I say one a week is a target that I consistently fail at. Even though that is a target that I set myself and I consistently fail. So if it's more like, I'm sure some people succeed with that, that's fine, I don't. And 10, 100, yeah, it's completely unfeasible. And I don't really know I don't know how you get past that, to be honest. There's some nice open source software journals are quite nice because they at least release things that you can implement. So there's the Journal of OSS, which tends to not release quite as much, but you can immediately then just take it and implement it. So that might be one way, but I don't know. Has anyone else got a good way of staying on top of papers? The machine learning R subreddit's quite good. That's all I've got, really.
The data science section newsletter is very good.
The data science section newsletter is very good, yes. Yes, Piers does an incredible job. I don't know how he has so much time to read it.
I mean, how can we guarantee that all those papers are actually correct anyway? No one can have time to even peer review them all.
Well, yeah, because it's just, whilst they come out in peer review maybe a year later, but yeah, agreed. And some of them come from sectors that aren't necessarily directly within the statistics and machine learning space, which sound amazing, and then you read through and you're like, oh, actually, this doesn't make any sense at all. Someone's just put a random thing together.
You're back to what you were saying earlier. It's incredibly specific and might solve one problem that then just isn't applicable anywhere else.
And the challenge then is how do you know it's worth putting it in your toolbox? You've got to know when and how to apply it, which means you have to know enough about it to know the flaws and the weaknesses, and that's quite an investment to work out whether it's worth knowing about. Is actually probably the best you can do. The slightly faster horse. I did a drawing of a horse. Did you think that looks like a horse? It's not a very good horse. I was glad that the path didn't come anywhere further to the back, because So this is what we should be really good at, is the solving of problems than words into computationally tractable solutions. This is what we're really that's the bit that makes us special as data scientists. And a couple of points we've heard is that people who are non-technical try and give you a solution. They're I need you to do this because I know this works in Excel or this other version of a tool that I use. I need you to do this, but a bit better. And I've seen quite a lot of projects fail like that, and I know other people have as well, because they say that that's what's happened. They were asked to do something, and it was not better, and it didn't make them valuable, and people then thought that data science was a bit of a waste of time. And there's a bit of a balance here. If people want a slightly faster horse, they just want a slightly bigger version of Excel, or I just want this little thing automated, even though it takes me 10 minutes already, you're not going to deliver value. So you've got to be slightly more proactive about solving a problem. And I think That requires a bit more kind of head-up space, which can be difficult, where you're looking at the whole kind of domain you're working in strategically. What is the most important thing I could solve for a business, rather than just, okay, what's being given to me? So I kind of picked some problems here which I thought either fit in or don't. Because there are some problems that people find really difficult. They can do them, but they're hard for people to do, and they don't think of them as being solvable by computers unless you're in this space. So like classifying topics in a document from 10,000 classes is possible. You could learn how to do that, but it's not very easy for a human being to do, and someone's probably not got a solution for that if they aren't aware of the techniques that you are aware of. So that's a great problem. If you could find that problem, build that solution, something like, oh my God, that is saving time. Put it in next month's sales numbers. It sounds intuitively like a really good data science problem, but if you just have last month's sales numbers and someone says, well, probably last month's sales numbers, that's a pretty good model. That's going to be quite hard to beat. And it's probably not worth, like you could build a really good model that's a little bit better, but it's not worth doing because no one's going to say well done. Because it took one guy one row to just plot forward and say that's great. Hospital activity into payment codes, again, that's a job. People do that, they have a career in that. If you can automate that or make that easier, that's a great problem. It's the same kind of thing. It's a hard skill that people are bad at, that they've had to do, that could be improved. Whilst that last one, I think, again, identifying faulty sensors, cool, yeah, it could build a machine learning model that does that. Or there could just be like a rule, which you just apply, and there's like a couple of lines of code for a software engineer. And that's just as good. So I think this is probably the subtlest one, because it's really tempting to go after problems you can definitely solve when they're not the right problems to go after that's going to make you really valuable as a data scientist. I don't know if anyone's got other examples that are a bit like this. I'm struggling to think of many of them.
I can give it one that came up just this last week in my team, because we do real-world data science, and somebody came to us, well, we've got all these biosamples. This contractor we hired has been through the data up and down, but we don't like anything that's come out. Can you spend time on it? The goals haven't been defined. It's a small sample, and somebody's already poured through it. Not worth our time.
Yeah, someone's already done it. They think, oh, can you just do the magic? And you know that it would be effort, and yeah, that is a good example. That taking on someone else's job because it's not quite good enough, and you might be able to do a better job. Yeah, so I think saying no to that is important, and people don't really do it very often. So like the two risks I think that come out of that from the conversations is, A, if you wait for people to bring you problems, you're going to miss out on the big ideas. So you do have to be proactive and think, okay, strategically, what could I do that they haven't thought of? And don't improve on things that are good enough, because they're good enough for a reason, and if they're usable, don't touch them. You'll make yourself look bad by doing it.
Maybe I could just add something quickly, because it's a very interesting point, which totally right, it is one of the hardest ones. And I was lucky enough in 2017 to work in an organisation where there was lots of automation to be done. So information management function 4 days a month could be quickly automated to 30 minutes. But that then became the selling point of the science, because these reductions in time spent have been seen as so valuable. But we quite quickly used up those opportunities and found ourselves with these other ones that were much harder to make the case for in terms of the value of that automation. And had we been more strategic about it, had we been to this presentation, we would have thought this is coming. This moment. Maybe we should plan for it, because there'll come a point where we'll run out of these very nice, ready-made automation opportunities that are computationally very straightforward, but people see the value of immediately. And we need to start making our case in different ways.
How did you solve it in the end?
We ended up broadening out what we were doing, not working only with the courses functions, but doing internal consultancy on lots of other.
Yes.
It ended up broadening out what we were doing. So we ended up working with many different teams, not just their course reporting, information management functions.
That's a very good way of doing it. Kind of, if you solve one client, what other clients exist that aren't exactly the same, but have the same kind of problems? Yeah.
No, but I agree with you. That's probably the hardest one so far as we talk through.
Yeah. This one is not hard, but I think it's more alluring. The two quotes here, I think they're really, I feel this quite a lot as someone in the corporate world. People do really want answers, and they pay for answers. And you have to explain to people that sometimes there aren't answers from a given body of data. That there aren't reasonable answers. But the counterpoint to that is, if you do want to get an answer, and you really torture it, you'll get something. And this creates this kind of situation where I think as people who value truth, veracity, kind of being honourable data scientists, as it were, you can be put in a really difficult position by the corporate structures around you and the organisational structure, because they will want answers that you may not want to give, and there's pressure on both sides. So this is where it gets a little bit ethical. I don't know many of it. I've come across this a few times. Like someone from business, oh, brilliant. So we've got a new PR team. We just need some killer stats. How great this AI scream is. We've written the article. Just you fill in the gaps, put in the data, ready to go. And yeah, just add that significantly statistical stuff you do. Make it pretty, right? And that's a job you've been asked to do. And so again, this is hard because you may have to turn around and say, look, I'm sorry, you can't come to the experiment at the end and ask for the answers. You're going to get the answers. And this XKCD, I don't know if you know the full cartoon. It's a famous one. You will find something eventually. You will be able to say it's statistically significant. They will be able to put it in their PR. But you're going to kind of devalue yourself a little by doing it. And I've definitely done it in the past, and it doesn't feel good. You see a press release and you're like, I'm not comfortable with that anymore, and I wish I hadn't pushed through with that, and I wish I'd said no. Because, yeah, again, this is a horrible expression. Like the decision-making process is sort of oiled by the data rather than driven by it. It makes things easier, but you haven't pushed it forward. It's not built into the structure. It's not the kind of the salt of the meal. And people will think you can do that, which I think is even more dangerous. That they'll go, oh, well, last time you did it, can you do it again? And then that becomes the process. They come up with the idea, you find the data to fit the answer that they want, and you continue. And you did it once, so why not do it again? And you start selling snake oil. There's not a good way of getting around this. You just have to push back against things. And if someone's bought something, it's really, really difficult to, but it's about being an honourable data scientist, I think. Do you know if any reflections on this one? Because, this is, anyone been in this position? Yeah.
Can you use the code of practice for statistics?
Yeah, exactly. So as a chartered statistician, I sign this thing, so I can't do this, this, and this. And that's a great thing to fall back on. The job with data science is because it's not you can do the professional qualification now, not many have, but because of that, people don't always have that to fall back on. I agree. I found it really useful to have a charter to say, I've signed this, so, but yeah, be careful. This one's just comms, right? The very clever sausage machine. And we're all very clever people working in a difficult field, doing hard things, and we want to tell people about how clever we are. And people really don't care. Because they haven't bought your clever model. That's not what people have bought. They've bought something that makes something better, cheaper, easier. Their jobs, their lives, their business. That's what they've bought. And I've seen lots of, if you start explaining to stakeholders, management, the rest of the engineering team about how clever your model is, or all the processes, and kind of chuck up a load of math on the board, it is quite tempting because that's what you've done. And it's like, this was really hard, and I worked really hard at it, and give me a gold star. But it has another, a downside to it, which is that people don't necessarily think you can kind of speak human because you don't use their language when you talk to them. And so they feel like it can feel, and I've seen people do, it can feel like you're trying to impress people and make them feel stupid. And this happens for engineers as well as non-technical people. As you're the expert in that thing, and it's up to you to speak to them in the language that they're comfortable in order to make them feel okay with what you've done. It's not really your job to make them think that you're clever. And this is, I think, externally and internally something I've seen a lot, and it's difficult to fix. It's being people-focused rather than model-focused, because it's not academia, and it's a different world. And the second to last, the faceless. This is, something, this was again raised I think this was in the Wales talk. We were talking about the impact of the models on decision making and the ethics associated with it, and how that fits together. It's hard, it's easy to make models, and sometimes it's hard to remember that is a person underneath it who's generated that, and so there's going to be an impact from that in a way that isn't necessarily expected, so there's going to be a side effect. And we talk about bias. I think bias is one of the great things we speak a lot about now. Okay, there's a bias in your model, we're going to fix a bias, we're going to split up all these different dimensions and see if there's a bias in that model. Great, there isn't, we can go ahead. But there's a human part of the story that sometimes we miss. So the story that we heard was like a model that predicted the profitability of a store over the next 5 years based on demographics, purchase behaviour, and so they were going to close some stores. And there's a store that they found in a remote location that fits the criteria.
It's not Benbacular, is it?
Pardon?
It's not Benbacular, is it?
No, it's not. And this is what the model is meant to do. It's meant to find places to save money because that's what the model is doing. And it's not a person, it's just a store. But again, this was when they took into account, this was the only store for like 4 different villages, and it was the only one that had a cash point, which actually meant that if you shut down that store, it would have a huge knock-on effect for the local community. And everyone would be really upset, and it would be like really damage that kind of societal fabric. So they didn't do it. Your model wasn't wrong. There's nothing you've done that's particularly wrong, but the decision making that goes with it has to have that human element as well. And so I wouldn't have thought about that at all. And because you're really happy with your predictive accuracy, and you're like, this is great. Let's just shut this down and make the money. But it doesn't work like that. So it's always incomplete, and you can't really quantify the value of that ethical behaviour. And yeah, that kind of humbleness and being empathetic about the gaps that you have in your knowledge, so that when decisions are made, that's okay. But people sometimes push the model too hard. So, well done, everybody. You kind of walked the journey. And the joy of the end of this journey is the management tightrope. So this is start drifting into what we spoke at the beginning, the organisational side. And people have excelled as a data scientist, you have more responsibility, you've been asked to manage a team. And so what happens is people's calendars fill up with meetings, the team need technical advice, stakeholders want weekly updates, the comms team needs something, another team would need some advice, you need to interview candidates, the finance team more about compute, like suddenly it's a very different job. And this is what is happening to a lot of people, and again we heard a lot of frustration about this, is that this isn't a technical career track, there's a management career track, but it's more senior. So is that good, is that bad? And there isn't an easy answer in this, but I think it's very easy to fall into like that lead role by accident, and because that's what someone will ask you to do doesn't mean you should do it, because it requires a set of skills that are actually hard. Like that, in the same way that coding is a skill, project management is a skill, technical scoping is a skill, people management is a skill, and you need to train and practice and need to know if that's what you enjoy doing. Otherwise, you're going to really hate your time and feel really bad about not doing the job you want to do. This overlap, I think kind of the engineering manager I'm not really talking about as much, probably that middle bit there, the hiring, project management, there's this sort of overlap that people get into because they become more senior, and it can feel quite disempowering. And again, I think that's almost where people feel the most kind of on the shelf because they're not doing their job anymore. So I guess this is just sort of questions that some people I've spoken to people who've done both, and this is kind of their list of what's useful and what's not. Kind of, are you productive on your own? Because you've got to be able to help others. You've got to be good enough at your job to be able to lead others. Are you comfortable coding less? And if you're not comfortable coding less, then definitely don't do it. do you enjoy mentoring others? Because if you don't enjoy that, then don't do it. This fourth one is, are you excited to solve problems, but not actually solve them yourself? I look at that and I go, oh, no, no, I want to still do, but that's part of the role. You've got to hand things over and let them do it. And the final one is really important, is that do you believe in what you're doing enough to persuade your team that it matters? So are you going to be able to provide the leadership that's required to get the job done? Again, that's not an ornamental risk, but that's what's going to happen if you succeed, and this then becomes an important question, and there's got to be a deliberate decision. So that's the journey we've taken. We've gone through unspoilt lakes, domain deserts, random sota forest. So, do people say sota or sota? What do you think? Sota? Sota. Faster Horse, Wizard of P, Sausage Machine, The Faceless, the management typewriter, and now people are efficient, effective, and ethical appliers of the statistical algorithmic tools of the trade. That's the hope. That was the way of becoming a data scientist that is not ornamental, and we'll stop there and do a Q&A. Are there any questions? Was that straightforward?
I do have a question. It's been a really great presentation, but something I've been ruminating on, and I wonder if you've come up to any conclusions. In data extrapolation.
Mm-hmm.
So in data extrapolation, we always are creating models based on old data, and what you really want is more than that. And I've had situations where somebody says, oh, you can just, do a smoothing curve, and in the health sphere, oftentimes my advice is you absolutely can't do that because it implies you have more data than you do. You can't smooth across 4 points and say, look at my curve. And that's, of course, an absurd example, but is there any kind of rule of thumb or advice that you've come across for data science at large? How many points is enough to do a smoothing curve? Or not very specifically, but broadly. When is it making up a model, and when is it data-driven?
That's a good question. That makes me think of the problem we're having with COVID at the moment, and kind of projecting forward years of data over that COVID period and beyond, where people go, well, let's take 2018, 2019, and then we'll skip out till 22, 23, and we'll just project forward, right? That kind of thing. You can't say anything about that. So you have to say, you pick. You have to tell people you can choose scenarios to go for, but that's not a model. That's just people making guesses about the future. So I think that's a case of there is so much uncertainty there that it's very difficult to quantify in a way that will enable meaningful decision making. So you have to, in that situation, I think you have to run scenarios rather than say, look, we've quantified the uncertainty. It's either this or this. There we go, because that's not a very useful answer. And people want to make decisions off the back of it. So whatever helps that without pretending the data is accurate.
Thank you.
And again, it's part of your role as a data scientist or statistician to push back if someone asks you to do that.
Yeah.
I had to do the same thing with the senior VP of R&D,
Yeah.
who should have known better. 4 data points. Is this a curve? Can you predict what's going to happen next year? It's easy when someone's really senior. Sorry. It's easier when someone's really senior to just go, yes, we'll do that for you. But actually, it's wrong. And you just have to have the courage and conviction in your own skills to push back. Easier said than done, but try and do it.
Yeah.
Thanks. It's very thought-provoking. You mentioned data scientists doing coding. They're doing data governance, information governance, data quality, ML. You're now into courage and standing up for your convictions, ethics. Are we asking people to do too much, or is that part of the fun? I'm interested in whether that's come out of your discussions. And from that, do you naturally get these specializations because a full stack data scientist kind of peters out over time?
Yeah, I think the easiest distinction there is like the IG, the legal side of things. In the same way that I not a lawyer, but know which laws I shouldn't break. And in the same way that not a mechanic, but know how to drive the car. That's the principle of taking, how do I navigate the ideas I have through the world without breaking other stuff, I think is the best way of thinking. I do think we're asking a lot of people, because to be technical and to listen to people and to be able to present and to deploy models feels like too much of a job. But until there's more specialization and until the organizational structures are there above to work out how it should fit together, people are left to prove the value. You need to do a lot more than other people, because it's an and job at the moment. I think that's, yeah, I don't think there's a way around that until we have structures that make the best use of people.
Yes, thank you. Very, very interesting talk. Basically, what you mentioned is 100% what I need to deal with each day. So my question is about industries. So how do you feel how all the difficulties that you mentioned differ across industries, like banking, retail? I come from the gaming company, and it feels that what data scientists, the challenges data scientists face are different industries.
They are, for sure. Yeah, I guess I've experienced in kind of the retail, a little bit of gaming and gambling, pharma, health, less on all like the pure public sector, the kind of governance side. And what changes, A, what you're allowed to do, the kind of data you're dealing with, like is it sensor data? Great. Is it people data? Bad. And the problems you can solve. So in a company where you'll deploy models, and that's like, it's a software company and that's what they do, you're going to have a very different job, because you're going to be working with a back-end team, a front-end team, you're going to have QA people, it's going to be quite smooth, and you're going to be a small part of a cog in a machine. Maybe in a retail company which doesn't have that infrastructure, you're going to be expected to do a lot of that yourself and be a bit of a one-man band, and then you're going to have to know, what am I allowed to scrape from this page? What am I not? Oh, how do I store this? Am I allowed to keep this? Like, then you're going to have to. So it comes with both industry and with scale. And I agree, it's going to be different. But you need to work out, what do you need to know in order to not break things?
Thanks very much. That was a really interesting talk. Really appreciate it. The quick version of this question is whether you think it's important to come up with a generally applicable definition of data science and data scientists, because it was interesting looking at your different differentiations between those role types. But from my point of view, I think about large public sector organizations, how long it takes them to change their structures, to have roles incorporated into their organizational hierarchies, and then how quickly methods and their possible applications are changing. So in some sense, having some flexibility to the definition of what people are doing in those roles is helpful, even within organizations and within roles. What they're doing and how their priorities are changing, you might need some flex in it. But I also understand that generalizations are not helpful. But the problem with not tagging things in the right way is that if times become leaner, then you risk, if you're relying on people who are named information managers or statisticians, but are actually driving a lot of useful, innovative data science across your organization, if they're not tagged as such and times get leaner, you might end up losing them because you haven't clearly identified the value that they're giving to the organization. So I wonder if as the section, and you personally given your experience, think there is something you could do with that definition that you used later in your presentation about taking a problem that's in words and turning it into a tractable computational solution. Obviously that's quite informal, but is there a way that could be formalized in some way to be used in a general context? Thanks.
Yeah, I like that as a concept, because I agree in the public sector it's people are in a really awkward position because they have the classic example at the moment that I do. The NHS calls a data scientist administrative and clerical. That's the category it's in, which means that they can't do a lot of things and they can't hire the people they need, because the administrative and clerical pay banding and budget associations mean that no one can really do the job they're being asked to do. But the flexibility that you've outlined means that we're still figuring it out, that is a luxury that we have. We can say that you are somebody who, do you code? Yes, there are the features that make someone a data scientist. Can you present? Can you communicate? Do you know enough maths to know when to not make a mistake? But it's worth doing, I think. I think having some of like the technical side of it, the ethical side of it, and the kind of soft skills side of it can be put together. The advanced data science practitioner, I don't know if you've seen that application form. Have you read through it? Do you agree with a lot of that?
So I've seen it, but I haven't yet read it, but I look forward to seeing what's in there.
Yeah, it is good. It does. I think it probably veers. We went back and forth with them a few times, Trevor, and seen a few iterations of it, and I think it's a good start, and I would veer towards that for the time being. I'd also think there's there are other groups like the APHA, APHA, which have put together job descriptions and like a data engineer stream versus a data scientist stream for the public sector, which I think are also useful. But all of them do still move towards management, and none of them are talking about a technical track. So that is the bit that I think we do need to fix. And how can we prove the value of technical data scientists as they become more technical and better at doing their jobs? How do they have a career which doesn't require management in the same way you would have for a pilot? You don't ask pilots to pilot multiple planes. That's not the right. Yeah. Anyway, you get the idea.
Super. Thanks.
Yeah.
It was interesting mentioning the framework for data scientists. Am I coming out of the speakers?
Yeah.
Okay, good. Because I have looked at it. A lot of it is, I'm a chartered chemist. A lot of it is, like being a chartered anything. It's you have to behave ethically. You have to remember health and safety. All that sort of thing. My problem as manager is that basically we have people who've been grandfathered into the data science role from kind of adjacent ones. And so it's just trying to work out a core set of competencies that everybody needs to have before they actually really count as data scientists from the point of view of, say, benchmarking against other organizations. Because I want to make sure that everybody's remunerated fairly, but if somebody's specialism is natural language processing and a bit of stats, that's going to be very different from somebody whose specialism is web scraping and dealing with big pipelines and that sort of thing.
Yeah.
So
I'm
not sure this is a question.
No, but you say stats, and I think we're at the RSS conference, right? And that the stats part and the probability and understanding, I think that is core. I think the statistics is the grammar of science and the way to extend knowledge, and that knowledge aspect of data science is the bit that I find most appealing. And I think you can do a job there of saying, right, given a piece of data, can you try and get to as close to the truth as possible, given the mathematical models you have at your disposal? And can you understand like what's happening there? The idea that you just, can use a model to predict things, that isn't a data scientist, because they're not. That you need to have a level of understanding about what's going on in the real world, and convert it into something and understand why. And I think that should be fairly universal across data scientists in any profession. And then the other bits on top.
Yeah. I was a bit horrified to talk to a data scientist in a other similar organisation who was looking at download data, and they hadn't taken into account the rotation of the Earth around the Sun, or the birth of our Lord, or
Well, like, but that's the domain side. If you don't know that, and like what that person might be great, but in your head they're an idiot because they just didn't you haven't thought about it properly, and that's why that's just so important to know. What are those little things that someone who's expert in this would ask straight away to stop yourself looking like an idiot?
Thanks very much, Will, for a really interesting talk. So I'm an academic statistician, I would call myself. And so I was enjoying your journey because I think there's lots and lots of parallels and lots of things I could agree with. The management tightrope, I think, is not unique to data scientists. I mean, in academia, we face exactly the same thing. And I wonder what you think the solution is, because generally what happens with these things is maybe there's a more technical track, but then the decision just comes up at a higher level, essentially. So do you see there's some solution there at all?
The way I think about it is that you have two things you need to optimize in your career choice. One is the autonomy you want to make decisions and pursue things within the organization, and one is the ability to have deep focus and solve technical problems as a data scientist. Now, if you want to solve deep problems, you can do that and you will go down a technical track, but the problems that you solve will be handed to you in a way that you won't be able to control because you're not making the strategic decisions as to what the organization will be doing. On the other hand, if you are interested in making sure the organization goes after the problems that you want to solve, you need to be in a position where you have the authority or the bargaining power in the hierarchy to do that. And those things, I don't think you can have both, or if you do have both, you're a unicorn. So that's right, and people are going to value some of those decisions as more valuable because they make a bigger impact to the business, and you can only do so much as an individual contributor. So that's, yeah.
Okay, and no questions have come through on the app. So what I would
probably one at the very back.
I would encourage people to, if you've got extra questions, add them to the app. We can always answer them later. You might not have thought of your questions yet.
When you mentioned the management tightrope, I actually thought you were going to talk about something different, and that's this sense that so you alluded to it with your example of the co-op. Is that the data scientist does the data analysis, comes out with the predictions, the forecast, whatever it is that they're after, and then those are taken away off them, and somewhere in a darkened room somewhere else, decisions are made.
Yes.
And so, and I have a particularly egregious example of this from earlier in my career when I presented these beautiful forecasts, and they got sent off to management. They didn't like them; they were too high, they were unacceptably high. So I'd very helpfully for them presented the uncertainty as well. So they just took the lower bound as forecast. And of course, needless to say, this had consequences going forward. But my question is really: to what extent should the data scientists, cross that tightrope and get involved in the decisions? Because actually, decisions, of course, can be can be technical issues that they can involve eliciting utilities and things like that, and they're not they are things where you need technical experts. To what extent should that be also the role of the data scientist?
I think it's a good one. I don't know, Trevor, you have an idea about this? I have a view.
Put me on the spot now.
Yeah.
I think it is very tricky. In my company, I get involved in the decision making, but there is an element of seniority in that. If you're a junior person doing the analysis, you're probably just going to hand it on, and then someone else will have to help with that process. But it's really difficult. You talked earlier about actually getting hold of the data, talking to the people that matters, understanding the data. And sometimes if you fully understand the problem, that can give you some ethical dilemmas when you even go to that level. Yeah. So a bit like your shop example, I've gone to the factory floor to get information from people, and they're really helpful. And then in the back of your mind you think, but I'm doing this to automate your job in the future and you're going to be made redundant. Yeah. But I've got to gather that data to really understand it. So yes, you want to get involved in that decision making so that you can gather the data correctly, so that you can inform people directly. But then again, it's that tough decision. You have to stick to your guns. So like the data you were presenting, don't let them take that lower example, push back, say it's wrong. It's hard, but you have to do it. Yeah. And if that ultimately means you'd have to leave that company or you feel uncomfortable with that, you've got to do it. You can't be unhappy your whole career. I think it's easier now. The career expectations are you are going to move between companies. You're not going to spend very long at a company, and you're more likely to have a career path by bouncing from job to job. I mean, I think you've already done more different companies already than I have, Will. Now I've done 3 in 34 years, and you're on what, number 5 now?
5,
And
I think, yeah.
yeah, so it's a very different area now.
The only bit to add to that, I think, is I agree with that entirely. The consequences side of things, like I find it useful when you're explaining what to do to people who are non-technical, saying, okay, we're going to do it this way. What this means is these kinds of changes are going to be really difficult. These kind of changes are going to be really easy. And the consequences of these decisions are going to mean this in the future. And if you choose these are the consequences. So just, again, getting out of the, I've got a clever machine that does clever things, into these are the consequences of the decisions that you're making if these different scenarios happen. Sometimes helps, but it's hard because people still don't listen.
I just wanted to kind of build on what you said a little bit, because you said maybe if you're junior, you're not so responsible, but I feel like in mentoring, that is probably the most important stage of impressing on a data scientist their responsibility. And I try to do it with young statisticians, young data scientists, is make them feel the responsibility of their work. I don't know if I'm very successful, but just trying to connect. I know this just seems like you're doing an assignment and handing it in, but downstream this could affect somebody's health, and think of somebody you know and how it could affect them. And I think all the way through, no matter how junior you are, as much as you're able, because of course seniority means you have a bigger picture, try to feel the responsibility.
Yes, as I have hard opinions about the decision making, yes, I need to speak up. Yeah, so first, absolutely, yes, it's important to help junior people to feel responsibility and ownership, so that participate in decision making 100%, because it helps them to feel, again, ownership of whatever company is doing. But for me, the last decision should not be on data science, even head of data science, because the decision should be made by the most knowledgeable person in the room, and it's never head of data science. There are always people on the business side who know whatever happening with data pipelines, whatever like a C-level or senior management want to do, strategic goals, some problems with whatever it is. So from my point of view, data science is consultancy, and the data scientist should always be able to say, yeah, like, yes, roll out treatments because there is a high evidence of that it works, whatever it is. But the decision is not on data science, again, because we are not the most knowledgeable people, so we cannot make this decision. Often people want us to make the decision, but we should not.
Yeah, that's right. There's extra data that's not in your data set that needs to be included.
Yeah.
Just add to that, I work in sort of, I don't know what you describe it as, semi-academic, so I work for a government-funded research organisation. And I think we sort of spot this as being the difference between decision support and decision making. And that we spend our time providing the evidence to support decisions rather than telling them what the decision is. And it's somebody else's responsibility to make that decision about whatever it is, whatever science is going on.
And it needs to be very clear who that is.
Absolutely.
Otherwise it sometimes sounds like it's your decision.
Thank you, and I can't help just making a quick comment to follow up some of these ones, to say that from our experience, it's the place where training and mentorship can make the biggest difference. So if you're working with a technical team and junior data scientists are used to talking about assumptions, talking about covariates, and explaining the technicalities of the model and discussing it within the team to make it better, the jump to a very small window of time and attention and different reception to explaining some of the ins and outs and uncertainties and consequences to decision makers is one of the things that can be learned, but it's very, very hard to get right from the first point of call. And so that's something that we spend quite a lot of time trying to train ourselves on and also train other people on. So if the RSS or the data science section would like to provide more training on that, I think it'd be fantastic, because communicating that, there's 2 risks for us. One is you end up annoying people with technicalities, as you've talked about in your talk. I've seen that happen a lot, which means you just lose your window, closes completely. And then making sure you explain the right things, like the consequences, is the second part. But that's something that we would like to do more on. And if there were more public good resources on how to do that kind of training, to switch between that technical level to engaging decision makers to do the proper sort of decision support, I think that'd be fantastic.
Yeah, it's not explainable AI or explainable machine learning, it's how to explain, which is a different thing. Like, it's like, is it explainable? Yes or no? How do you make it meaningful to someone when you talk to them, which is a different skill entirely. That's a good idea. The number question, I'll just add that if people are interested in joining the data science and AI section, or people are interested, we are looking for new committee members over the coming months, so please do get in touch or just come see me after this talk. So again, thanks again, that was really good, lovely discussion. Thanks all.